So I have the immense privilege to talk this morning and kick off this session regarding artificial intelligence. And when we talked about artificial intelligence, and my slides are not going to work, obviously, artificial intelligence is more than just artificial. Artificial intelligence is actually very real today. Numbers of companies have been using what we call applied intelligence, starting with automation. Automation is what you do when you have large quantity of processes that you need to repeat over time, and that you like to scale with the power of a computer and applied quantity of times so that it repeats and you can gain more productivity. It starts also with analytics. Analytics, when you get data which is raw data, and you'd like to convert it, process it, clean it, store it, and then display it so that you can take actionable decision. And finally, on artificial, which really has been accelerating for the past couple of years, mostly for the past 5 to 7 years, with the rise of what we call machine learning and deep learning. And this is all about augmenting human ingenuity. So what happens when we drive an algorithm? It's all about getting data, raw data from sensors. So it's sensing data. It can be IoT. It can be a video camera, which is capturing data that usually is not very well seen because only 2% of video camera footage is being looked at. It's about capturing data from IoT devices that may be or not corrupted. It's cleaning this data and it's comprehending this data. And this is where the algorithm is going to play to extract information, the location of a building, a swimming pool from satellite imaging, the text, the data which is captured in an invoice. And this is going to be then used to act and leverage this information so that you take informed decision. So sensing, comprehending, acting is at the core of what you do with an algorithm. What's really new with artificial intelligence for the past couple of years is this ability to learn and do continuous improvement. And that's where we would like to focus on. So at the core of an algorithm, there is, we talked about very different algorithms. We talked about deterministic one, which is being used in automation. And we talked about what is being used more in machine learning and deep learning. And this algorithm has been through a surge of usage for the past couple of years. Why? Because there is accelerated computing power. There is more data available with the cloud. And therefore, there is more data that can be used so that you train your algorithm and that you make them readily accessible for the larger number and for all the industries. So at the core of each algorithm, there is usually, a very limited set of untrained algorithms that you train for specific application. So that you train them to do voice to text, so that you train them so that you do intent detection, so that you train them so that you apply computer vision and you can detect what is visible and accessible in an image. And most of the solutions, artificial intelligence solutions that we see out there are a combination of these building blocks. So if you talk to a virtual agent, or if you talk to your voice bot at home, what you realize is basically there is a succession of these different building blocks that have been trained for a specific purpose. You talk to your voice bot, what happens is you do a voice to text so that you get a transcript of what you just said. You get intent detection so that the robot, as a cobot, actually understand what has been said and what is needed to be applied. So if you want to book a ticket for a flight going to Paris tonight, well, it will understand the intent, the time of the day, and then it can raise and connect to the website through automation and get the information back, and then convert it through text to voice so that it generates an answer and you can have a normal discussion in a fraction of a second. And all these different building blocks is what makes a complex solution, and this is what you have been using every day, and we talked about smartphone earlier on during the day, and that's what is hundreds of times being replicated on your smartphone in all the applications you use in your daily life. Okay? So nothing really complex around that, but it's always about sensing, comprehending, and acting around the data that is coming from all the sensors around you. So a couple of applications that are out there and that my team is actually delivering on. We talked about fraud detection, which is a very typical use case. You learn about the train, you try to detect the weak signals and leverage this information so that you can drive better outcomes for your industry. You talk about document understanding, we talked about satellite imaging, and we have use cases for precision agriculture, for instance. So you look at satellite imaging and you say, well, is the crop growing as fast as it should? Is this area of that field growing as fast as the other one? Do I need to water this field or not water it too much because I'm just going to overspend on this area of my field? So you can do precision agriculture, and you can use the same technology for tax. And that would be less popular, obviously, in the region, but if you have a swimming pool and you should not have one, well, satellite imaging can help with that, okay? Identity recognition used to be only available on the airport. Now it's coming to your smartphone, and now you can open your laptop and get access only if it recognizes you. So it's really democratizing, and it's gaining in trust because it's more readily accessible, and it's actually more precise than it used to be. And this technology is going to be open so that it's being used so that you get into your car without the need of even a key, and you can start and get the perfect sitting condition for driving to your place. So all of these different examples, intelligent contact center, I mean, customers in the telcos, in the banks, insurance, they have millions and millions of calls every year. What if we were using the same kind of technology we talked about regarding virtual agents, and we scale them so that we can answer most typical questions? When you get into a situation of emergency, like a tornado, well, you get millions of calls at the peak point. And if you want to treat them efficiently, you need this kind of technology so that you can spend time on the most complex cases. So these are the typical cases we are working on today in the industry. And the artificial intelligence and the applied intelligence is real. 2/3 of the industries are using it today. And many of you in the room are using it on different use cases. And it's actually proven to be something that is working to a limited extent. Sometimes it requires more data. I had a great discussion with some of the participants earlier in the day, and they told me about the complexity of getting the right amount of data to train an algorithm. And that's something that used to be true a couple of years back, but actually it's getting thinner and thinner. Why? Because we are surrounded by numbers of pre-trained algorithms. So you take a specific application, you take, for example, facial identity recognition, you realize when you are using an application that you only need a couple of your pictures so that it recognizes you. Because the algorithm has been trained on millions of pictures out of Facebook of people are freely tagging an individual to a picture, and therefore the algorithm is already trained, and it just needs to be specialized for your use. And that requires much less data. And this is the kind of algorithm we are using in the industry. When we do quality control on a supply chain for checking that a product is of the right quality, we put a camera, we take picture, and we use the same kind of algorithm so that we detect whether or not the output of the supply chain is actually the right one at the right level of quality. And to do that, we need much lesser images than we would have needed 5-10 years ago, because we can use pre-trained algorithm. Okay? And I don't have my next slide, but that the impact is what? The impact is that it's actually positive on work. What our survey shows is that actually industries that invest in the right use of artificial intelligence, of applied intelligence, are going to create more work, and they are going to go through an accelerated growth versus the others. But it needs to do that in a way where human plus machine have a bigger impact. And why is that? Because there is new job appearing. We talked about all the great application of artificial intelligence, but I mean, to achieve these great goals, you need people to train the algorithms. You need people to explain the algorithms. And you need people to sustain the algorithms. And I mean, training the algorithm is getting the right data and training it because you have experts who know what is the outcome you look forward to get. Explaining the algorithm is because you need legal teams, you need experts who know what algorithm to use in certain conditions. You will not use the same kind of algorithm when you are in a situation where you have a very regulated environment. You are not going to use the same algorithm when you are talking about autonomous driving. When you are talking about autonomous driving, you need to be 99.99999 precise on where the car is going to drive, because you cannot get any chance to get an accident. Okay? And that's a different algorithm. And in some cases, you need to be able to explain the algorithm. And it's more important than the total success rate of your algorithm. So all of this situation leads to selecting the right one and being able to explain the algorithm. And the last one is about sustainability. And this is the right place for data scientists. And we know we have a very limited number of data scientists which knows how the underlying algorithm works, but that's the place where they need to be, because sometimes an algorithm becomes obsolete. The complexity of the images, the text, the voice that is being handled becomes too much, and we just need to use another one. And at the core of what we were describing earlier, it's not about the quantity of data, it's just selecting the right algorithm so that you can train it. Okay? So there is a quantity of jobs where human can help machine, and then there is a quantity of jobs where machine helps human. When we were talking about satellite imaging earlier, all the data being generated by satellite imaging is a quantity of data that cannot be interpreted by in-human condition, because it's too much. We just need to convert all of this data into something which is actionable, looking at the right building, looking at the right crop, looking at the right swimming pool. Or in other situations, just finding the right spot where you need to drill down for getting some oil for a company that is interested in finding the perfect spot and driving its business. So data is extremely important, but it needs algorithms to be leveraged and create the right condition for business. And the topic of the session was obviously about facts, and more recently in the press, you have seen that the facts is sometimes leading to the fantasy. We know that MIT recently is able actually to create fake celebrities. So what's really interesting with deep learning is you take an algorithm end-to-end, you revert it, and instead of recognizing who is who, you can use the reverse algorithm to generating new faces. And this is an example on the left-hand side about the kind of new faces you can generate. So if you train an algorithm on recognizing celebrities, well, you can generate fake celebrities. Okay. Step 2 is something you have seen on the press maybe over a year ago, which was Obama, maybe it's not playing, but Obama talking something he would never have said in real condition, live conditions. Which means we can now impact videos and make people say something they would never have said. And it looks really real. And we have seen seminar videos with a lot of very well-known people. The point about number 2 is that it seems restricted to an elite and that very few people could drive those. The reality is different now, because through an app, you can now take your own face, take the face of someone you know, and put it in a video so that it plays out as if they had been acting this thing. Okay? So now, what is the difference between reality and fake? How are we going to live in a world where we don't know what is actually true, because it's so easy and accessible for the larger number of us to do these kind of things, to change a voice and say something that the person involved would never have said, to take a video and use it so that you replace it with someone else who has not been part of this scene. That is going to change dramatically the way we envision and we embrace the reality. And at the core of that is really the notion of, if we want to develop applied intelligence, we need to do it responsibly. And I know it's going to be a big theme for the day today. It's a way to kick it off. But responsible AI comes with trust. It comes with making sure you use the right kind of data. It's making sure that you use this data, trustworthy data, with people who have different backgrounds, with data which is making sure that it's driving gender equality and more, to ensure that we are not repeating the bias that we had in the past. And we need to make sure also it's reliable, because we were talking about driving conditions earlier. The more reliable, the more acceptance you will get from the algorithm. And then we need to be understandable, because we want to understand why such a decision has been taken, so that your treatment as a patient was going in that right direction. Or you want to understand why you got a credit or you didn't get that credit that you were eligible to get. So trust is at the cornerstone of the digital economy. We know that over 85% of the people using digital today really rely on the trust that digital is conveying to them, and that's why it needs to be at the cornerstone of the responsible AI that we are building for us and for our business tomorrow. Thank you very much.